Hi everyone, myself Surendran R, working as a data scientist in Spark Foundation. Today we are going to see about the task 2, that is prediction using unsupervised machine learning. This is a level of beginner. From the given iris dataset, predict the optimum number of clusters and present it visually. Here we can use R or Python. Now we are going to use Python. The dataset is given in this following link. Let's move on. The problem statement is prediction using unsupervised machine learning. From the given iris dataset, predict the optimum number of clusters and present it visually. Here we are using k-means clustering. That is one of the unsupervised machine learning. Here the step 1 is importing all required libraries, that is pandas, numpy, lux and cbun. Lux is already in my previous video I said about lux, and get it back into the video, and everything, the skill and pre-processing scale, k-means cluster and everything. That's all. And the step 2 is importing the data. This is the path the data is stored here, and we are calling the data into a pd.read underscore csv path. Here is the data. There is a 1 2 3 4 5 6 columns. Here the 2 columns is about the ID and the target. The species is the target where you can see. Let's jump it into what kind of distribution over there. This you will get only you use lux. It's a specialty of lux. Okay, this is the distribution throughout the data in this data set. There is a 50 odd values equally distributed. Setasa, varies color and Vajika. Let's see the shape of it is 150 cross 6, 150 50 50 50 for each color. There is a 3 color, and the step 3 is we are dropping the target and the ID. This is not required for the machine learning algorithm, so we're dropping these two things. Seeing the column names, and we are dropping this ID and species. Okay, so initially we are copying this data, then we are dropping this. See, we have dropped this and this, we left out this, and we only use these things. Okay, now you can see only that sepal length and sepal width and petal length and petal width is there. Again we are using standard scalar. Here we are just standardizing the data to a unit values, that is scaling line. We are using skill and pre-processing. From that standard scalar we are calling standard scalar, then we are calling into iris 1 this s1 fit transform into that iris new. Already we are pre-processed data is there in iris new, so we are calling here. Then the output will be in the array format, array matrix format, so this cannot be imported in directly to the algorithm, so we are converting into a data frame. That is, the output of the function scale is matrix. We need to convert it back to the data frame in order to keep on using it as a data frame. So we are using the converting it into data frame. Let's see now. Yeah, it's converting to data frame. This is standardized values across the columns. This is a description over that column, mean and standard deviation. The standard deviation is most very small here. The step 4 and the final most step is k-means. Finding the optimum k-means is the process of the k-means. So we are taking the only values of the 4 columns into x, and we are importing the k-means, and we are using within cluster sum of squares. If the optimum k-mean is found, then the cluster sum within cluster sum of squares will drop. the WCSS. Let's see, we are calling 1 to 11 k numbers, and we are building an algorithm and appending that data into WCSS. let's see let's see the plot and find the optimum number. Now you can see that as the number goes on, the values drops, and there is the optimum elbow point. This is the optimum elbow point, where that above this the values keep on reducing in a gradual manner, in a very little manner, very slightly manner. So we choose this 3. 3 is the k-means number here. From this we choose the number of cluster as 3. So we are from 1 to 11 we are choosing 3 as a cluster number from the elbow method. This is called the elbow method. Okay, then we are applying the number of clusters equal 3, then iteration k means plus plus, and maximum number of is 500, and n initiates is 10, and the random state is 1 to 3. Maximum use a random state. Don't leave out the random state as 0. It will give your optimum values and good score. Let's see, this is the answer. The cluster is somewhat 1, 2 and zeros. The zeros are first one, the iris setasa, and 1 is iris varies color, and 2 is iris vegiga. So we are plotting this into a graph by this sort of code. Let's see. Yep, you can visually see that the versicolor is almost predicted, clustered into a group. See, this may be an error, sort of error, and this also sort of error. This is almost 90% good, and 95, almost 90 to 95% good, according to k-means cluster. That's all. This is the k-means clustering. Thank you. If any queries, leave the query in the comment section. I will get you back. Thank you.